So again, good day, everyone. On behalf of QSG, I would like to welcome you to today's webinar, AS9145, the Aerospace APQP and PPAP Overview by Laura Halleck. QSG is committed to providing up-to-date, useful, and credible information on the topics that you care about. Thank you very much for joining us for today's webinar. We hope that everyone is safe and healthy. My name is Angelo Skangis, and I will moderate today's webinar. Today's webinar will be approximately 60 minutes in length. Laura will make a presentation for about 45 minutes, and then there will be a question and answer session. We welcome your questions, please. You can ask a question by using the chat box on the top right-hand corner of your screen. Type your question, as many questions as you want, and I will collect those during the webinar, and I will announce those to Laura after the presentation. To make this webinar as effective as possible, we ask you to please go on mute on your phone or your computer, and also please turn the video off on your computer to reduce any possibility of Wi-Fi stress now that everybody's working from home. But please use the chat box for your questions. Everyone should have a presentation from today. That was attached to your invite. There's a PDF document that was attached that you can follow along with Laura's presentation. I think that's all the pre-webinar stuff that we need to cover. Now I would like to introduce you to Laura Halleck. Laura is a senior QMS consultant with QSG with 19 years of experience in manufacturing, engineering, quality assurance, process improvement, Six Sigma for various industries, including the automotive, electronic, aerospace, and defense. Laura's background includes quality system development and implementation, for all the various standards, including ISO 9001, AS9100, and IATF 16949. In addition, Laura has done extensive work in supplier quality management, as well as internal and second-party audits. Laura specializes in guiding organizations through quality management system certification and maintenance, including gap assessments, systems implementation, training, and internal auditing. Her training specialties include root cause analysis, corrective action, AT structured problem solving, automotive core tools, which include PPAP, MSA, SPC, FMEA, and control plan, and of course, the aerospace APQP and PPAP, the topic of today's webinar. Laura is certified as a lead auditor in IATF 16949, AS9100, and ISO 9001, and is also a Six Sigma Black Belt. In terms of education, Laura received an MBA from the University of Massachusetts in Lowell, a master's degree in industrial and systems engineering from Georgia Institute of Technology, and a bachelor's degree in industrial and management engineering from Russell-Lear Polytechnic Institute. Laura, thank you very much for taking the time to do the webinar today, and I'll turn it over to you.
Okay, thanks, Angelo. Good morning, everybody. All right, so our topic today, as Angelo mentioned, is the AS9145 Aerospace APQP and PPAP process. A little bit about the AS9145 standard. Previously, many companies, aerospace companies, were just referring to the AIAG, APQP, and PPAP handbooks, but they figured out that that really wasn't working to their benefit. So they developed the AS9145 to standardize the requirements for the product development process through the use of APQP and PPAP. This establishes common integrated requirements for aviation, space, and defense industries. And the main reason why they needed to do this and separate out from the automotive approach was to tailor it based on the uniqueness of the aerospace industry with low volumes, long life cycles, and higher levels of regulation. A little bit of history of APQP and PPAP. We're building on the principles of quality planning pioneered by Deming from the 50s and the automotive industry during later decades of the 20th century. In around 93, 94, the big three automakers in the US published the first combined APQP and PPAP manuals for the automotive industry. In 2013, the first aerospace APQP was published. And then in 2016, the AS9145 APQP PPAP standard was published. So it's still a relatively new standard. It's becoming more and more mainstream as more customers are starting to flow down the requirements throughout their supply chain. APQP is a structured process for new product development, includes the critical tasks from concept approval through production. It's broken down into a 5-phase process. So we have the planning phase, product design and development, process design and development, product and process validation, and then ongoing production and post-delivery service in phase 5. I'll give a brief overview of each of these phases a little bit later on in the presentation. So the purpose of APQP is to provide a structured method to ensure the new products satisfy customer needs and wants. It works to drive on-time and on-quality delivery of product by monitoring key project deliverables, establishes a mechanism for early detection of quality and design problems, and also provides opportunities for continual improvement. The benefits of APQP is to help satisfy the customer with improved product quality because we can better anticipate and mitigate risks, eliminate defects, and reduce process variation. Reduces lead time by reducing waste and rework and better managing our capacity, which drives to overall lower costs. One of the key tenets of the APQP process is organizational commitment and management support. We need to ensure that top management is engaged in the APQP process. They should be part of APQP training, responsible for allocating resources to projects, leading periodic reviews of the overall APQP program, standardizing APQP practices across the organization, and also removing roadblocks for the APQP project team. The success of the APQP program depends on support across the whole organization. It's very important to have management engagement and commitment from product launch through closure. Another key aspect of APQP process is for it to be managed through a cross-functional team approach. We want to get away from silos or single departments running through the various aspects of this process. Typically, we include engineering, procurement, quality, sales, field service, and others as appropriate. You may include some key stakeholders, such as your customers or suppliers, depending on the scope of the project. Within the project team, you want to make sure you have key roles defined. The team leader or project manager that determines the team, assigns tasks, and can escalate issues to management. Team members who are responsible to complete the required tasks and deliverables. And then also someone responsible for management of the APQP process itself to ensure on time and on quality of deliverables, documents, and records. In some cases, this may be the same as the team leader or project manager. In some organizations, this might be a separate individual. The biggest benefit for running these projects and cross-functional teams is it drives better communication across the various functions involved in the process, which helps us to achieve faster results. Another aspect of APQP is project planning. So really what we're focusing on here is a structured approach to scheduling our tasks, assigning responsibilities, driving on-time completion. The APQP plan cascades the program key targets throughout the supply chain. So from your customer throughout your organization and then down to your supply base. And you need to be continually monitoring your plan, communicating risks, and removing roadblocks. The first phase of the APQP process is the planning phase. The objective of this phase is to identify and gather all inputs applicable to the product, collect technical and non-technical requirements, both from the customer and internally within the organization, define your product and project goals, ensure the organization makes key make versus buy decisions, which things will you make in-house, which things will you outsource or purchase components, and establish timing for your APQP deliverables. The main outputs from this phase are to have a initial product concept or pre-design available and a preliminary BOM available. I often get asked why in this planning phase we want to have so much of the product concept and BOM completed, and it has to do with the complexity of the project is going to be dependent on that concept, and the costs involved in the program are going to be related to that preliminary BOM. So it really gives you a better sense of planning for the rest of the project. Phase 2, product design and development. The objective of this phase is to turn product specifications, generally driven from our customer requirements, into robust product definition, provide a verified product design, and a team commitment to the manufacturability of the product. Phase 2 cannot be considered complete until the team agrees that the design that's been produced will be manufacturable. They don't have to know exactly how they're going to manufacture it, just that it is manufacturable. And some of the key outputs and PPAP deliverables are the design record, being any drawings, specifications, material specs, and the BOM, bill of materials. The design risk analysis, which the AS9145 does not dictate the approach to be taken, but the common approach is a design failure modes and effects analysis, and a product design verification and validation. Some of this validation activity will happen later on through phase 4, but we'll have some initial prototype and simulation type verification here in phase 2. In phase 3, process design and development, our objective is to create a robust manufacturing process that meets the requirements in terms of quantity and quality of the product, and define the means to control the manufacturing process and its outputs. The key outputs here are the process flow diagram, the process failure modes and effects analysis, FMEA, the control plan, and packaging, preservation, and labeling approvals if required by your customer. Phase 4 is product and process validation. The objective of this phase is to collect data that demonstrates manufacturing and assembly processes can produce conforming product at the required rate, and determine the process readiness for entry into serial production. Phase 4 is where we run what we call our significant production run, so that we can take the data that we're going to be using for these deliverables listed below, the measurement system analysis or gauge R&R, our initial process capability study, where we analyze our CPKs, approved first article inspection report, which is our standard AS9102 format, and our approved PPAP. So phase 4 is primarily around generating the data that we need to submit our PPAP and obtaining the approval from the customer. Phase 5 is production, use, and post-delivery service. The objective of phase 5 is to evaluate if the project objectives have been achieved, record the lessons learned to drive robust product realization processes, and implement actions to increase customer satisfaction. Our outputs here are that we've achieved our project goals, including reliability, quality, customer satisfaction, and on time, on quality, on cost, production, and service. So phase 5 is really about continual improvement and reducing variability once we have launched into production. When we look at APQP reporting, there's a couple of different things we want to look at. One is assessing our deliverables, looking in terms of on quality according to checklist criteria, and on time according to our APQP timing. The checklist criteria is referring to, there's a set of checklists for each of the deliverables, the key deliverables available through the supply chain management handbook. And I've included a link to that at the end of this presentation. And there's a rating system of red, yellow, and green. Green would be that everything on the checklist has a positive answer and is being completed as planned. Yellow is there may have been an issue, but there's a plan to resolve it and no impact to product delivery schedule. Red would mean that there would be some impact to the final product delivery schedule. And when we're looking at APQP reporting, we're looking at it at various levels. So your customer may be looking at an overall product, and perhaps there's another tier that's looking at it from a systems level. You may have a piece of a subsystem driving down to your suppliers with their various components. And the key here is to identify where there may be impacts to the overall schedule throughout the entire supply chain. Your customer may ask you to provide certain input so they can do this type of monitoring of the overall project. This is an example of a project dashboard. I know the text is very small, but just to give you a flavor. So each phase here, phase 1, 2, 3, 4, 5, these would be each of the deliverables in the phase. And if it's been completed and on time, it's showing in green. In this particular example, the red items are just items that have not been completed yet. So we can quickly look at a dashboard for a particular project and be able to see, oh, this project is in phase 4. It is not yet fully completed, customer approval of the PPAP, so it's pending phase completion. Moving into the production part approval process, PPAP. PPAP is focused on determining whether all customer engineering design record and specification requirements are properly understood, and demonstrates the production process has the potential to produce product consistently meeting customer requirements during actual production run at the quoted production rate. This ties into what I just talked about in phase 4 of the APQP. The benefits of PPAP are to help maintain design integrity because you're checking between the supplier and the customer that we're both working towards the same revision levels and the same specifications. Identifies issues early for resolution. Reduces warranty charges and prevents cost of poor quality. Assists with managing supplier changes because you can do it additional PPAPs to qualify those supplier changes over time. Identify suppliers that need more development. So if you have 2 or 3 suppliers of a similar type of part and they've all submitted a PPAP and one is struggling to pass their PPAP and the other ones are passing easily, then you know where you need to focus your efforts for supplier development. And also improves overall quality of product and customer satisfaction. When is PPAP required? So whenever you have a new part or product, it could be that you already have that part, but it is now going to be supplied to a new customer. That may also require PPAP. If you need to correct a discrepancy from a previous PPAP submission, any engineering changes to the design records, specifications, or materials for the production product or part number, and any other additional requirements as specified by the customer. So the best way to think about it is PPAP is required with any significant change to your product or process. The aerospace PPAP file is made up of 11 elements, and this shows the phase that each of those elements would be produced in. So coming out of APQP phase 2, the product design and development, we have the design records and the design risk analysis, or DFMEA. Phase 3, we have the process flow diagram, process FMEA, control plan, and packaging, preservation, and labeling approvals. Sorry. And phase 4 is the MSA, the initial process capability studies, first article inspection report, any other customer-specific PPAP requirements, and the PPAP approval form. And note there that the design risk analysis is only applicable for design responsible organizations. However, the design records must still be submitted even if your organization is not design responsible. So even if all you're doing is taking the customer specification that they've provided to you and putting it into your package and submitting it back to them, it still needs to be submitted to them, because we use that to confirm that everybody's on the same page, working to the same revision level. So I'm going to cover some of these specific tools at a high level to give a little bit of an overview. First being the design failure mode and effects analysis, the DFMEA. The DFMEA provides the potential cause and effect relationships for the basic design of the product. It identifies risks related to product performance as a result of design errors, identifies, prioritizes, and tracks completion of appropriate risk mitigation activities, such as changes to dimensional performance or material specifications, tolerance stack-up or simulation analysis, and design verification testing analysis. Here's an example. I know it's difficult to see on your screens. This is the DFMEA template. It's just showing you, we have the item, function, requirement, the potential failure modes, potential effects of the failure mode, a severity ranking based on that effect, the potential causes, our prevention controls, occurrence ratings based on those prevention controls, detection controls, and detection ratings. And then the score is calculated here, the RPN, or risk priority number, which gives us an indication of priority for taking action. And for our high risk items, we document the actions we've taken and rescore. I did spend some time trying to find some examples to share with you. Unfortunately, all the examples I have are sort of company specific, so I don't have a generic example to share with you. But this template can be found at the IAQG Supply Chain Manual Handbook website, and that link is at the end of the presentation. The next tool is the process failure modes and effects analysis. So it works this very similarly to the design FMEA, but its focus is on the manufacturing and assembly of the product, identifies key process inputs which affect quality, reliability, and safety of the product or process, and identifies, prioritizes, and tracks completion of appropriate risk mitigation activities such as work instructions, visual aids, operator training, implementation of detection controls such as inspection, and error proofing. And these detection controls will feed into your control plans. Again, this is the template, similar, same fields as the design FMEA. The control plan links our manufacturing process steps to key inspection and control activities. The intent is to control design characteristics and process variables to ensure product quality. It considers our design record requirements, our process flow, our design FMEA, and process FMEA outputs. So it basically ties together all of these other pieces. And we need to make sure we're reviewing it and updating it whenever changes occur or in response to new quality issues. I do have an example of a control plan here. This is related to a assembly of a chair. So we're looking at the product characteristic. In this case, it's a part orientation for this assembly, and how we control that part orientation is through an error-proofed fixture. The frequency of control here would be continuous because it's error-proofed. So there's no action plan required in that case because it's error-proofed. The process characteristic here is the fixture itself that we're using for the alignment, maintaining a position within a certain tolerance. And we're going to verify this error-proofed fixture using calipers once a month and recording it in a log sheet. If we find it to be out of the tolerance, then the reaction plan is to tag the fixture and submit it for repair. That's just a brief example of how the control plan can be used to document the controls you have in place for your process. Another tool I want to talk about is Measurement Systems Analysis, MSA, also known as Gauge R&R. The difference between the two terms is that MSA refers to the entire various types of analysis that can be done on your measurement systems, where Gauge R&R is a specific study particularly done for variables data. So when we look at our data, the measurements that we take, we have some level of observed variation that's made up of our actual process variation and our measurement system variation. The measurement system variation can be broken down into precision, which is a measurement of variability, and accuracy, which is a measurement of the central location. Precision is looking at resolution, repeatability, reproducibility. Accuracy is looking at linearity, bias, and stability. Generally, the accuracy is validated through calibration of our measurement equipment. And we want to make sure that we are using calibrated equipment before we do an MSA study to look at our precision. Very briefly, resolution is the number of discernible digits on an instrument. So for example, a micrometer has a much greater resolution than a ruler. It's important to make sure that the proper measurement tool has been identified for whatever measurement is being taken. If in your MSA study you find that you have an error in resolution, it means there's an inability to detect small changes, which is generally because of having the wrong measurement device selected, or the divisions on the scale not fine enough to detect changes. Repeatability is the variation between successive measurements of the same part by the same person using the same instrument. So under identical conditions, do we get the same results? And this generally is attributed to variability of the measurement system itself, but can also be caused by a lack of training or standard operating procedures, so the operator is doing it slightly differently each time. Reproducibility is a difference in measurements made by different people using same or different instrument. So an error in reproducibility is an inability to get the same answer from repeated measurements under various conditions from different inspectors. And that's generally due to a lack of a standard process or a lack of training, that things are being done differently each time. I'm not going to go into the details of how to run the study here. I just wanted to give a little bit of a brief overview. Process capability is another key piece that we're going to be looking at as part of our PPAP submission. This identifies the extent the process is likely to produce items acceptable to the design. Our key characteristics with a CPK of less than 1.33 for aerospace require 100% inspection or measurement. In automotive, that level is 1.67. So aerospace, the number is a little bit lower, and that's generally because of the lower volumes that we're dealing with in aerospace industry. So this is just some examples of what our process can look like. In the top left corner, we have a process that is capable and centered. In this case, our CP, which is a measure of the width of our process variation without looking at where it sits in the spec limits. When it is centered, our CP equals our CPK, and it's capable, so greater than that 1.33. This example, it may even be greater than 1.67. In the top right, it's capable, meaning that width is reasonable, the variation is reasonable, but it's not centered. So our CPK would be very bad there. In the bottom left, we have a process that is not capable, meaning we've got way too much variation, but it is centered in this case. And in the bottom right, it's not capable and it's not centered. So our variation is too wide and we are shifted off from center. So of course, ideally, we would like to have a process that looks like the top left. But if we don't, the next best thing is actually to have a process in the top right. So even though our CPK is very poor here, because the variation is small, we should be able to make an adjustment to bring to center it and bring it within spec. Or if we know we've got very tight variation and we cannot adjust the process, we may be able to get the customer to approve a spec modification because we're so predictable on where we will fall. And the bottom left is more challenging because even though we're centered, it is much harder to reduce that process variation. And then the final piece is the PPAP approval form. This is the document that gets submitted to the customer. This section in here lists out all of the items that are required elements, whether they've been included, not included, or NA if there's a particular case where something was not required. And then the customer can sign off on this side if they've accepted each particular element and make their comments. This section in here allows you to document any additional actions for anything that wasn't meeting requirements or needed further improvement. And then the customer signs off at the bottom. I did not include the first article inspection report form, the AS9145 form, because that's been around in the aerospace industry for a long time, and I wanted to keep the focus on sort of these newer aspects. These references here where you can get additional information. So through the IAQG website, there's a 9145 guidance document, as well as the 9145 2016 standard itself that you can obtain. And the supply chain management handbook, I'm referencing here section 7.2 for APQP, but there are other sections in the handbook that can be really helpful as well. There's a section that talks about MSA, section that covers first article inspection and things like that. So definitely take a look at that. If you haven't before, you can sign up. It's a free access login, and you can download a lot of all of the templates and a lot of reference material. There's much more available for free through IAQG than AIAG provides for automotive suppliers. And with that, I will turn it over for questions.
Okay, thank you very much, Laura, for a very good presentation. I know it's difficult to get into detail with so many requirements to this process, but I think there was a good overview of the requirements. So we do have a couple of questions from the people attending. But first of all, I want to say that this webinar is recorded, and if you're interested in obtaining a copy of the recording, please email Chris, and he'll send you a copy, so you'll have the recording and the presentation as well. So one of the questions has to do with the AIAG VDA new format for FMEAs. Is the aerospace industry transitioning to this new format from what you're aware of?
Currently at this time, I'm not aware of a plan to transition. The IAQG just recently updated their FMEA templates in December of 2019, and it still sticks with the same format with the RPN scoring as we had previously. I wouldn't be surprised if over the next few years, as the new 7-step AIAG VDA approach becomes more mainstream in automotive, I wouldn't be surprised to see that approach start to pop up here as well. But for right now, if you are supplying to, if you're an aerospace supplier or supplying into an aerospace customer, I would stick with the formats provided through the supply chain management handbook.
Right. Very good. Another question concerning FMEAs, and this is a great question concerning integrating FMEA methodology in the supply chain. And the question is, it's amazing how many customers have not documented a DFMEA as part of their design and development process, but they are requiring it from the suppliers to the organization, requiring a DFMEA, a PFMEA control plan, and PPAP. Can you comment on that?
Yeah, I find that to be the same case. Many of my clients that I work with and provide training on, if they're not design responsible, and I always tell them, you know, you should be given the design FMEA as an input into your process FMEA process, and I don't think any of them have ever gotten that. So yeah, that is certainly an issue, and it's an issue both in the aerospace industry and in the automotive industry. I think part of the problem there is that even if your customer has developed the DFMEA, a lot of the information that goes into a DFMEA can be very proprietary, and it's difficult to share outside that organization. So they may have completed it, but not be willing to share it, or they may use a different tool or different format. Ultimately, the key thing that you need to be able to do your process FMEA is an understanding of the effects of the failure modes and the severities. So if you are unable to get a design FMEA from your customers to provide inputs for that, then I would ask the customers to just give you an understanding of the application of the product, the effects, the severities for you to use as an input to your process FMEA. So even if they haven't done the full design FMEA, they should still be able to give you some inputs to use as a starting point for your process FMEA. I do agree that it is a little bit frustrating, but a lot of times as suppliers, we don't have the power over the customer to force them to do that and give us the full design FMEA. So we just do the best we can with what we have.
Very good. While you are on the FMEA topic, can you talk a little bit about the linkage between FMEA's control plans and flow diagrams?
Yes. So the process flow diagram, which I did not include in my overview, but a process flow diagram should indicate every step in your process from receipt of raw materials through shipment of the final product. And the reason why we want to include all of those steps in our flow diagram is so that we remember to account for them when we do our process FMEA and our control plan. A lot of times those manufacturing, non-assembly steps, material handling, movements, etc., are actually areas ripe for defects and errors to occur. If we think about, for most companies, many companies, their biggest customer complaints come down to packaging and labeling issues. The product itself is fine, but it's logistical type problems. So we need to make sure we include all of those steps in the process flow diagram. And then in our process FMEAs, each of those steps in the process flow diagram will be reflected. So here we have a process step. This would be the step from the process flow diagram. And we'd analyze the failure modes associated with that step. And then in the control plan, the same idea. We have the process step here. These would be the same steps from our process flow diagram as well. So those three are tied together. If I add an additional item into the control plan, because I know I need additional inspections, then I need to go back to my process flow and add that inspection step, as well as go back to my FMEA and make sure I've analyzed the potential failure modes associated with that step.
Okay, great, thank you. Next question has to do with process capability, and it's another great question. Process capability studies are usually based on a usual volume. What if your entire build never reaches that volume? What is AS willing to accept?
Yep, this is one of the key differences between the automotive standard and the aerospace, in that there's an understanding with the aerospace standard that the volumes are different, in many cases extremely lower. The main reason for needing to do a process capability study is so that you can use sampling in your product acceptance. So for automotive, if your CPK is greater than 1.67, or in aerospace it's greater than 1.33, then I can use sampling for acceptance. If my volumes are so low that I can easily do 100% inspection, because every single piece that I'm building, I'm taking measurements on, then there really isn't a lot of value in the process capability study. And in those cases, that's where you can work with your customer to get approval to provide them with the data for each shipment or each product. So then in that case, maybe a CPK isn't necessary. If you won't have that volume in the initial, quote, significant production run that we try to do as part of our PPAP submission, maybe in aerospace, instead of building 300 pieces, maybe we're only going to build 5, and I'm not going to have that volume, then what I would do is provide the data for all 5 of those samples. Hopefully they've all passed, and are all acceptable. And then over time, as I continue to produce that part, I will continue to take that data so that I can look at how it's performing over time. But again, the CPK isn't really necessary at that low of a volume. And AS9145 allows you to have agreements with your customer based on those low volumes to make adjustments to the expected deliverables.
Okay, and I think that answers another question concerning how the aerospace industries is handling or adjusting to low volume, to the aerospace low volume industry. So I think you answered that question.
Yep.
So can you also talk a little bit about customer specific requirements? How do customer specific requirements, how they're integrated into this APQP PPAP process?
So that's works similarly to the automotive approach, where obviously if any modifications that your customer makes or any additional requirements that they have would be included as part of the PPAP package. I believe it was item 10. So depending on your specific customer, what they flow down through their supplier requirements manuals will dictate what additional items or what modifications you might have in customer PPAP requirements, certain volume requirements, things like that, that answer some of these questions based on, what the product is for that particular customer. So it works fairly similarly as with the automotive, where it's one of the items listed out in the PPAP file, and it could be a myriad of things just depending on the customer and their needs.
Okay. So another very good question, Laura, has to do with when a PPAP is required.
Mm-hmm.
This is something I think, you and myself and other people that have been working with the automotive and aerospace industry, this has been something that we've been struggling with. I think always when a new part is going for approval, we all know that a PPAP is required, but there's many other occasions where a PPAP is required. So the question is, it appears that a new PPAP is required for any change to the customer technical data package or the supplier technical data package. Where does the PPAP fall within the engineering change order process?
Yeah, so one way to look at it is if you are making any changes that affect any of the items in the PPAP submission package, it most likely will trigger the need for a new PPAP. Whether your customer will require you to run samples, if I've made some sort of product change, then I may need to repeat my production run and take my data and repeat my CPKs and my MSAs. If I've made simple changes where I've added a visual aid or a form or something to the control plan or the FMEA, but I haven't changed the form, fit, or function of the product, then most likely I'll be able to submit just the specific document that was affected. And in those cases, you would notify your customer of the change that you're making and find out from them what specific requirements they have, what documents you need to update, etc. As far as how this ties in with your ECO process, it should be a specific step in your change management process where you look at, okay, what is the change? Does the change impact any of these elements? If it does, here's the notification process or the approval process. Who's assigned to do that communication with the customer? Is it going through a quality person, an engineer, a customer service person? Somebody's assigned to send that notification to the customer, get the feedback from them of what they need for the updated PPAP. And from that point, the product should be considered back into the APQP flow at could be at phase 3 or 4, depending how significant the change is, potentially even phase 2 if you're making a change to the design records. And then you would manage it back through your APQP process to get through the PPAP submission and approval again, and then you'd be back into normal production. So yes, it definitely needs to tie in with your change management process. It should be a checkbox on your change notification form to confirm whether any of these elements have been changed, and then trigger activity to follow up with the customer and get their guidance if it has triggered any of those changes.
Very good. And just to follow up on that is how, in terms of changes in the supply chain, you have some critical suppliers that may change location of manufacturing, may change the process flow or something with a test process. Would that also connect to the ECO process for the evaluation of re-PPAPing?
It depends in your particular quality system how you are managing supplier changes. Some companies handle supplier changes through their ECO process. So even if it doesn't trigger a change on their part, they still go through the same type of approval process to provide the approval to their suppliers, in which case, yes, you would integrate it there. If your system manages those changes through a supplier management type process, then you would trigger the review there. So it depends on how it integrates with your quality management system.
Right. Do you recommend that an organization clearly document the criteria for re-PPAPing, if you will, clearly, so everyone in the organization, including any auditors, clearly understand what the criteria are?
Yes, that's preferable. In some cases, some organizations are supplying to so many different customers with different requirements that can be challenging. So you may need to have some documented process for if one of these events occur, then we go and we review this customer specific requirements to see if this customer needs to be notified, as opposed to being able to have a hard and fast rule on how you manage the changes. If you're supplying to one or two main customers, then you should build your change management process around what the customer has flowed down to for their requirements.
Okay. Very good. I think that's all the questions that I see. If anyone has an additional question or you'd like to talk to Laura directly, feel free to open up your line and ask the question if you like. We don't have a huge number of people on, so we shouldn't be a problem. So if you want to open your line and ask a question, if not.
Yeah, let me just, if anybody has a question after the fact, if you want to reach out to me, I have put my email in the presentation. I think it's on the cover and on the last slide. Just make sure if you do, you point out to me that you were on this webinar so I know where the email is coming from. But yeah, I'm happy to field additional questions if things come up later on.
Very good. Thank you very much, Laura. And this ends the 1 hour webinar presentation. And I want to thank you and everyone that attended. I hope the webinar was useful and value add to you. Feel free to check our other webinars, the Quality Support Group webinars on qualitysupportgroup.com/webinars. We are running 2 webinars a week on the things that you care about. So we hope to see you at a future webinar. Thank you for attending today and have a great day, everybody. Bye-bye.